Welcome to the Whole Farm Podcast, brought to you by CHONEX, where we explore soil health, nutrient management, and the systems that help crops and farms perform better over time. Each episode features conversations with growers and industry experts focused on practical insights you can apply in the field. Whether you're managing nutrients, building healthier soils, or looking for data-driven ways to improve outcomes, this podcast is built to support real decisions and real results.
Welcome back for the second episode of the Whole Farm Podcast. I'm Michael Pisciotta with CHONEX. We have Les Riley, who's one of our sales agronomists in the Mid-South area. And we have a very, very special guest today. And so I'm super excited to be asking some questions with Les to Dr. Tom Dykstra. And so I'm going to turn it over to Les to give a brief intro of Dr. Dykstra, and then we're going to get into some pretty fascinating conversations.
Well, Dr. Dykstra, thanks for coming. I'm going to read part of your bio off your website just to kind of lay the groundwork, but want to get right into it. I heard about your work last year and have been fascinated by it, and Michael and I have talked about it a lot, and we're really excited to share it with the broader ag community. So, Dr. Dykstra received his BS in entomology from Cornell in 1990. He then went to University of Florida and received his MS in entomology in 94. Then he investigated neurophysiology of pheromone production in moss. Continuing in the University of Florida, he received a PhD in bioelectrical magnetics under Dr. Philip Callahan in 97, and then began Dykstra Laboratories, which more broadly investigates bioelectromagnetics ranging from bacteria to humans. Predominantly, he studies insect olfaction, how insects smell, from a standpoint of bioelectromagnetics, and has developed a new theory based on the fusion of biophysics and neurophysiology. So thank you for being with us, Dr. Dykstra. And if I butchered the pronunciation in those words, forgive me. I'm just a Mississippi farm boy.
Thank you for your Mississippi farm boy pronunciations. Yes.
That's awesome. Thank you, Les. All right, Dr. Dykstra, we're going to jump in. And so, this episode is going to be really focused on the science. And obviously, you're a scientist, but we're going to be talking to a lot of farm topics today. And one of those farm topics that, you have a kind of a focused thesis around, if you will, and you've proven in the field is around Brix and how insects relate to this topic of plant Brix. And when I say Brix, I don't mean we're building a house. It is a BRIX situation. And so if you could do kind of a science explanatory brief conversation around Brix. What is Brix, Dr. Dykstra?
Okay, Brix is a measurement. They use a refractometer usually in order to test it. At least we do now. They had some different devices back 100 years ago, but Brix is using the refractometer is now a measure of the bending of light. That's really what it is. And so when the light bends, we can measure the degree of bending and therefore get a Brix reading from that refractometer. That's in essence what it is. It was named after Adolf Brix. His last name is Brix, B-R-I-X, as you mentioned, Michael. And that name has stuck. So anytime we use that, we do have to capitalize it. So anytime we have a Brix refractometer, the B is capitalized, and that's the game that we play. But this has been around for a long time. What is it? It began in 1950s, really. So it was long before I was born. And Kerry Reams is the one who really started investigating it at that time. And it was probably about 20 years later before it really started to develop. So it was in the 1970s with Kerry Reams and a few others who were on the boat at that time, started investigating this phenomenon of Brix, and that is measuring plants using the Brix refractometer. What are they measuring? Well, it's really simple. They would just squeeze plant parts and get the juice out. And that's all this was about. And so while squeezing these plant parts, they would get 2-3 drops. That's all you needed. And then they would get a measurement. And this measurement told them something because it was actually measuring. See, when you're measuring, if you're measuring motor oil, that's different. You can get Brix readings from that. But if you're measuring plant sap, or at least the juice that comes from it, it's predominantly sugar. 85 to 90% of it is going to be sugar. And therefore, you will often hear when people mention Brix, you will hear things like, well, you're measuring sugar in the plant. And from a practical standpoint, that is true. From the technical absolute standpoint, we're just measuring the bending of light. But because we are measuring predominantly sugar, we often use this synonymously and say, yeah, we've got a Brix measurement, we're measuring sugar, and that's what we do when we are measuring plants. So that's in essence what it is, how the name came about, and where we are based upon the question that you just asked.
Okay, well, as we get through this, we're going to talk about how that impacts plant yield and particularly how it relates to your background with insects and what you've discovered. But tell us a little bit more about your primary research focus in insects, and then we'll move to how that got to Brix.
Okay. Primarily, I'm interested in insect olfaction. So I have been involved in looking at how insects smell and how they taste. And this is something which has been, I have to say, it's partially been in the back of my mind since the 1990s. It started to develop and became more important, and it's now one of the main parts of my research here at the laboratory is to decipher the insect olfactory codes for various insects. So I've got a host of insects that I have analyzed, taken a look at their chemoreceptors. And while analyzing this, I'm now able to tell what the insect is smelling, what the insect is tasting, and the degree to which it is smelling something and the degree to which it is tasting something based upon spectrums that I have been to develop in some of the proprietary software. So that is a little bit what I do. Now, this does tie into Brix because the insects are very, very interested in keying in on unhealthy plants. That's where they're smelling and tasting. They want to be able to smell an unhealthy plant. They want to be able to taste an unhealthy plant. And in order to do that, they have to be able to taste and smell effectively. And that's where I kind of came in. It was a bit of a back door. But in the process of taking a look at this, I did have to look into, and I was asked a lot being an entomologist about this whole Brix thing. And back in the 90s, I didn't know a whole lot about it. But I did know about the magic number of 12, and I was bothered by that because being an entomologist and a scientist, I thought 12 Brix is it. This is all we have after decades of research that Kerry Reams was doing back in the 50s, and now we've got charts on the internet, and all we have is 12, and 12 is anything higher than 12, the insects don't attack your plant. Anything lower than 12, insects do attack your plant. And I think you could imagine, as I did, I thought, okay, so 12.1, no insects attack your plant. 11.9, every insect on planet Earth attacks your plant. This cannot be possible. And I figured there have to be degrees. What happens when you hit 13? Are they even less likely? What happens when you're at 11 or 10 or 9? Do they become more and more? And as I was looking at this question, I ran across something unexpected. It wasn't just a matter of getting lower and lower on the Brix scale. I actually noticed trends. And these trends or trend lines showed me that it was actually specific insects that were attacking the plants at specific Brix levels. It wasn't just a matter of being above 12 or just underneath 12. There was a whole continuum of Brix levels that showed me that this phenomenon was going on. And so, I mean, I was looking at this for 15 years. And then I was asked to do a presentation in 2012. Holy smokes. It is amazing what has happened since 2012. So even though I am very much involved in insect olfaction, after that presentation really took off. There was a lot of interest developed around it. And I've had to develop the whole concept of Brix to understand it, put it into chart form, been presenting all over the world. And those were the humble beginnings of making this connection between the insects and the Brix and the plants.
Wow, that is incredible. So there's just a lot to unpack here. Thank you so much again for explaining a little bit more about bricks. Even I was under the impression, working in fruit agronomy, I'm always squeezing fruit. I'm getting, samples, and we always think about that as an analog for sugar content.
Mhm.
But really, there's so much more to unpack there, and we're going to get into that in a little bit. But you mentioned that this thing has really took off as far as conceptually into field validation. So my question is, you knew this number existed, you had heard about it, you wanted to go in, bring out some of these nuances, really understand differences in insect species versus crop speciation.
That's right.
And so how did you kind of start testing this from a lab level into field validation? Tell me about that process, Dr. Dykstra.
Well, that process is very, very slow because I was uh, doing some of this research at the beginning on the side. And so because I was doing it on the side, we didn't have a chance to actually develop the way that I like. Later on, farmers would ask me to come establish Brix levels on the farm. And at this point, it became a little bit more practical because I started to make some of these connections. And when you're on someone's farm, you see all types of insects and you realize that there are certain trend lines. And so when I saw a particular insect, let's just say I was looking at leafhoppers attacking a plant, these leafhoppers were attacking it, but I didn't see some of the other insects that I'm used to seeing. I would go on another field and I would see completely different insects, maybe even attacking the same species. This is how this slowly, and I mean slowly, started to develop when it came in and it became focused at this point. So when I had the refractometer and I was taking a look at the Brix readings, these trend lines started to develop over time, and I realized that not all insects are equal. And that is, some of them are able to attack, dare I say, you can get in trouble for this, more healthy plants, still unhealthy, and other plants far, very poor health plants. Other insects were attacking them, and some of the insects that went after a relatively high health plant were not touching it when we had a much, much lower Brix, and vice versa. And so, because we had this relationship developing, I was starting to put things together, and a chart started developed, a very easy to follow chart that I have put up on the internet. I presented my presentations, and this is now broken down the different feeding guilds of insects and where they fall on the different Brix levels. And so it's not just above 12 and below 12. Now I've got different readings, which usually give me about a 2 Brix window, which allow me to understand where the insects are going to go. So this is kind of how it develops. As far as doing the research, a lot of it was done out in the field. I would record the information. A lot of the virtually everything I do, 95% of what I do is proprietary, so I'm not allowed to publish, as some of the I think the viewers know. This is something which has bothered some. It doesn't bother others. But when you are doing proprietary research, you are not allowed to bring out specific information. However, it was the trend lines that was not proprietary. And so because these trend lines were not proprietary, I started to realize, okay, here's information right now, which I could talk about. Should I talk about? Because right now I've got other things to do. And at that point, I realized, this is back in 2012, and I thought, am I going to die without getting this information out? And I thought, is it really going to affect my career? Is it going to help me? Is it going to hurt me? Do I need to bother about this? And I thought, no, I think I probably should talk about this. I think, I did not know, but I think farmers would find this information useful. So I pushed the presentation for that first time and gave it. And I actually gave 2 presentations at that one particular conference. I can honestly tell you, I don't think a single person remembers the other talk that I gave. It was completely ignored. No one wanted to discuss it anymore. And it was all about this insect and Brix thing. And as I said, this has kind of snowballed. So this has slowly accumulated over time. Since 2012, I've had a chance in order to establish things, and I've been able to fine tune some of the Brix levels so we can understand the insects a little bit better. And I'm trying to split hairs as far as I am able. It's not easy to split hairs, but before the hair that we were splitting was above and below 12. So right now the hairs that I'm splitting are a lot better than above and below 12, but I can actually break it down to, the difference between an 11 and an 8 Brix. There is a relatively large difference between them, and the insects that attack an 8 Brix plant will be different than ones that attack an 11 Brix plant. So that's kind of how this all developed. All the information comes together. I've had a chance to look at the data. The trend lines appeared. I turned it into a chart, tried to make it as easy to understand as possible. Why? I want it accessible. You don't want people scratching their heads thinking, uh, I have no idea what Dr. Dykstra is talking about. That just went right over my head. And so I want to be able to say, look, this is what I've got. This is how easy it is to do. The measurement takes about a minute to do, and it can be done out in the field, and it doesn't cost you anything. So I thought we've got a cheap way to test this, and it's immediate. The farmer doesn't have to wait a week, sometimes 2 weeks, for the data to come back. It doesn't have to spend $85 to $150 in order to get a test done. And this information is telling them a lot. Originally, I didn't think the information was that extensive. Now that I've had a chance to look at all the Brix levels, there are clear physiological differences between the plants. And that is when I started splitting hairs and breaking it down and saying, wow, there are some clear differences. I can actually get a reading from a plant and tell you certain things about it without doing further testing, because the Brix has now told me so much about the plant. Doesn't tell me everything, but as far as inexpensive tests, you can't beat it. And as far as overall health, you can't beat it. This tells you the overall health of the plant. And so it has now come to the point where it has turned into something, it has morphed into something more than it was certainly in the 90s, and even more than it was in 2012 when I first presented it.
Well, I think I only have a little bit of time left in this session. We've got another episode. We're going to delve more into some of the practical applications, but two kind of related questions that this brings up is one, can you explain briefly why? So when we think of a high Brix score, if we know about Brix at all, like Michael knows that if fruit's higher Brix score, humans are going to like it better. And if you've got livestock, if your forage has a higher Brix score, the livestock's going to more ready to eat it and benefit from it. So why are more unhealthy plants more desirable for insects? And then B, essentially what you're saying, when we think of entomologists in the ag space, normally we think of a guy that goes out and says, here's the bugs you got, here's what you need to spray to kill those bugs. And
Yes.
what you're telling us is that you can give us the strata of Brix score that will tell us at this point this insect will stop eating, and then at this point this insect will stop eating. So rather than what insecticide do I need to spray, the question becomes, how do I get my plant healthier? So if you can elaborate on that, it'd be helpful, I think.
Yeah, I'm not even sure what the question was that you just said,
Sorry,
but
sorry.
but yeah, there are a lot of things to look at. So when you are looking at these Brix levels, there is a lot of information that comes out. There is some physiology, so you don't want to go into how technical do you want me to get right now? What would you like me to discuss first?
Yeah, yeah,
Uh,
yeah. If you can just tell us why insects like unhealthy
why
plants
insects like
and
unhealthy? Okay.
what levels,
All right.
you know.
That's a good thing. That's a good thing to start at. I should tell you, since 2012, I have been trying and failing miserably. I have been trying to say that it's not about the sugar that the insects don't like. This has been totally ignored by almost everybody on the planet. Everybody still keeps coming out to me. I still see stuff on the internet saying, well, insects don't like high sugar, and therefore they're avoiding the plant. And I never said this at the beginning. But I did say that there is a correlation between high sugar. And so people have just said, well, they don't like sugar, which is total BS, because we have nectar, which is coming in at about 30 Brix. Insects love it. We have honey and blackstrap molasses coming in at about 70 Brix. Insects will crowd around that in a second if you happen to drop it. And I have, sometimes it drips and some of it goes down and the insects come in. And if you put out pure small cubes of sugar, the ants will come in and carry it back to their nest, which is 100 Brix. So I just want to make it clear right now, and I realize I'm trying really hard right now, and I failed since 2012. I don't expect this to make any big difference, but this is not about sugar. It is about something else, and that is about the complete proteins. When you have a healthy plant, you have healthy proteins that are made. These healthy proteins are complete. That means the amino acid sequence code is complete. They are exactly formed the way that they should be. They exactly fold the way that they should. These complete proteins cannot be digested by insects. They can be digested by vertebrates. They can be digested by you and me. They can be digested by deer, by squirrels, by birds, and things of those sort. But the insects cannot break them down. They do not have the biochemical machinery in order to break down a lot of these healthy proteins. They need broken stuff. This broken stuff is what they are tuned to. This is what their digestive systems are tuned to. So when we are testing Brix, we're actually using it as a proxy for whether or not we have incomplete or complete proteins, because we understand that's what the insect really is looking for. That's what it can smell. That's what it can taste. And when a plant is not producing healthy proteins, it can't digest all of that stuff. And so because it can't digest it, it doesn't eat it and it moves away and it goes to another plant. So the sugar is an indicator that we use in order to determine whether or not the insect is going to be interested in a plant. Because in order to measure a complete protein or an incomplete protein, oh my, that is expensive. Very, very expensive stuff. You just can't go out into the field and start using expensive equipment in order to test this, but you can test Brix. And since Brix is an indicator of how healthy the plant is and how healthy the proteins are, that then tells us the level of health and what kind of insect we're going to see attacking it. So that's really the key. So we look at Brix, but the main focus is on these proteins, these broken down proteins, because that is what the insects can digest. They always want broken down proteins. They want partially digested, unhealthy plants that are not doing a good job of putting things together. And these broken down plants are more easily digested by insects. That's really the key. So I think that answers the question that we were looking for.
Yeah,
So
that's
that's a
actually
great
really
question.
That is, wow. Okay. That is really, really interesting from my standpoint because, I think you mentioned the word broken, which implies that we can fix it. And so I know that we're going to break this
good.
conversation down into two different parts, Dr. Dykstra. And the second part is going to be a lot about practical advice for farmers on fixing it. But I kind of want to know a little bit more about these insects because obviously they can sense this. But, you know, I guess, there's one school of thought that might say, well, let's just do something to take these insects out. But I would kind of want to just kind of wrap up this interview because I know CHONEX is a little bit in the insect business. But tell me some good things about insects. Like, tell me something interesting that we can wrap up because, this next conversation is going to be about kind of fixing these broken pieces or things and steps that are practical for farmers. But tell us something good about insects from your perspective. You spent your whole career on this and know a lot about it, obviously. And so what's your take on insects?
My take on insects is that they are indicator species. Anytime I see an insect attacking a plant, it indicates to me, one, that the plant is unhealthy, and two, the degree of unhealth of the plant. That is what I find so fascinating about insects, is that all of these insects, over 1 million species, and that's the good news. That's the good news from my standpoint. It may not be the good news that everyone's thinking about, because I know what some people are thinking about with good news, but I'm talking about the good news from the scientific standpoint, where we've got insects which are now telling us something. And if we read what they are telling us, we can learn a lot. Now, sometimes you could tell just by looking at the insect. I've gotten to the point where I can kind of get an idea of what the problem with the plant is just by the insect. But when you have that refractometer, you can put a number to it. That's so cool. And it's even beyond getting a 7 or an 8 Brix. I can come out and say with my digital refractometer, oh yeah, this is a 7.4 Brix. And this impresses people to no end because they're like, wow, that's really exact. But that's what the refractometer tells us. We can get very exact measurements. And so if you're trying to move up on the Brix scale, I always say we want to go at least 0.5 Brix. So if I'm at 7.4 and we put something down, a product, we can measure it again 24 hours later. And if it goes up to 7.9 or above, then that means the plant is doing better. That means it's photosynthesizing better. And these insects, these indicator species, are telling us that. That, to me, is good news to know. And because this is good news, I would love to get this information out. That's what I was thinking way before 2012. And when the opportunity came, and it has now been well received by so many farmers, is to be able to reach them with this information and teach them about this. It has been very fulfilling for me, and would love to do, many more years if this is what people want.
That's great. I'll turn it over to Les for the last question because we got about 3 minutes left in this first kind of session. But is it fair to say, Dr. Dykstra, that you mentioned insects as an indicator species? When you walk that field, you can take a Brix score with a refractometer. You can look and see if there's pest pressure. Is it fair to say that this is like if I'm driving a truck and I have a dashboard with lots of different signs, signals, indications? I mean, I would not drive a truck without a dashboard with knowing how fast I'm going. I could guess. I could maybe, look under the hood, check my oil levels, have a thermometer, check, temperatures. But to me, this sounds like a way better thing, right? I mean, this is a dashboard conversation,
Way
right?
better. It's much, much faster. You don't have to stop the truck, pop up the hood, and start looking at things. You can just look at your dashboard. You know exactly what the temperature of the engine is. You know exactly how fast you are going. You know exactly how many miles you have left before your tank goes empty. All of that information now, especially in the new cars, massive amount of information on your dashboard. And so when you have all of that information and you can determine it immediately, as little as a minute, that is powerful, powerful information for a farmer to have.
Awesome.
Okay, well, to wrap up this first segment or first episode, um, you've referenced a couple of times the charts that you've published.
Mhm.
Where can someone find that chart if they want to look it up while we're after they watch this episode?
There are a number of videos online that have that chart. There is one video that has just the chart, where it has me mentioning just the information on the chart. Essentially, it's an excerpt from one of my usual hour-long presentations. There are a number of presentations online. I don't even know how many there are that have that chart. I bring it up a lot. And so you can find it easily by looking for Brix chart, Tom Dykstra, these type of searches. It will usually get any one of a number of talks, and that should then lead someone in the right direction in order to find the charts that I'm referring to. But it's more than just the chart. Remember, I have a description with
Right.
that chart. So I could just put up the chart, and that's one thing, but I do describe the chart so that we can understand it, and I fill it out as I'm presenting so that everyone understands what I'm referring to when I'm talking about Brix, specifically the leaf Brix, which is what that chart entails.
Well, hopefully we can
That's
put a link in the show notes.
Sure, that'll be fine. That'll be fine.
That's it. That's why we wanted to do the podcast, because the show notes, obviously we can direct farmers to do things. We can direct them to go get a refractometer. Does it have to be something fancy, Dr. Dykstra? Do you have any recommendations? Because we know we're going to get that question.
Oh yeah. You're talking to the wrong person as far as fancy. Because if you said, should I get something fancy? My answer is absolutely yes. I want bells and whistles. I want neon lights. This is what I want. So there is an inexpensive refractometer on Amazon. You can get it for less than 20 bucks. Almost all of the refractometers are about the same. So if you want to spend, 20 to 30 bucks, you can certainly find those. They're all about the same. Those are the ones that I do not use generally. I have several of them in my repertoire when I'm out there, but I don't like to use them because I prefer the digital refractometer, which gives me the points, 7.4, 7.5, 7.6. It's easier for me to clean. It's very quick to move when I'm doing lots of measurements. So I like the bells and whistles. And I know what you're going to ask, how much does it cost? And I said, well, the good ones, I don't think are less than 120. So if you want a good one, mine is 300. So if you want a good one, I would be thinking in the three figures. And those are some of the ones that have worked out well for others. The one that I bought for $300, I bought, it must have been 30 years ago, 20 to 30 years ago, and it's still working just fine. So they're, I think, worth the money. If you're used to buying a $400,000 tractor, this is not a lot of money to you. So I don't think anyone should be breaking the bank by, even if they wanted to spend $100, $200, or $300 on a nice digital one. But if you want to go cheap, you can definitely do it for less than 50 bucks.
That's really great advice. Also, I would say get a great case, because they're going to fall
Yeah.
out of your truck a bunch.
Yeah.
That's just what always has happened to me.
They do
So
come with cases.
there you go.
Some of them do come with cases. Yeah. If not,
That's
yeah, put it in one. Yeah.
That's awesome. Well, we are going to wrap up part one for this interview with Dr. Dykstra. We got some show notes coming your way. I know a lot of curiosity is going to be generated by this first part. We're going to have a lot of your videos in the show notes that we can direct related to that chart and your explanation of it. When we come back for part two, the focus is going to be practical things farmers can do to manage what they're seeing as far as their testing and actually them going from field to field and trying to understand and put some practices in place. But thank you so much for your time, Dr. Dykstra. Thank you, Les. And we're going to wrap this episode up, and we'll come back with the next one in the next week.
All right. Fantastic. Thank you, Michael. Thank you, Les.
Thank you.
Thanks for listening to the Whole Farm Podcast by CHONEX. If you found this episode helpful, be sure to subscribe and share it with someone in your network. For resources or to learn more about CHONEX, visit chonex.ag. Thanks again for joining us, and we'll see you next time.